My name is Amanuel, and I'm going to be presenting fuel stabilization. So the Advanced Fuels and Reactor Physics branch has been tasked by the Environmental Remediation Management to provide technology and development for the support of the stabilization of AECL's legacy fuel. Now, this comes in a variety of chemical forms, such as pure and alloy, thorium, and uranium. Now, the Deep Geological Repository was proposed by the Nuclear Waste Management as the approach that has been accepted in Canada for long-term management. Now, non-oxide fuels would need to be converted into stable oxide fuels for it to be safe and accepted into the DGR. Now, the conversion of these non-oxide fuels to stable oxide fuels usually result in a coarse powder. And we found that the most suitable method to form these into compacts would be by using the spark plasma sintering. Now, before going into spark plasma sintering, it's important to understand what sintering is as a method. Now, this process is forming a solid mass through heat and pressure without reaching the point of liquefaction. Before going, the SPS was chosen for its various advantages over conventional sintering, as it has lower processing temperatures as well as a shorter time at higher temperatures, which would lead to fewer fission products coming out, as well as being a quick one-step process, which will last usually an hour or two compared to the conventional sintering that usually lasts a day or 12 hours. Now, as you can see, the SPS works by having a ram applied pressure on the sample, as well as a current going through the sample, heating it up. Now, this process shows great results as we have a control sample at around 30% theoretical density of UO2. And after it goes through this quick process, we usually reach our target density of around 90%. Now, as we continue this project, there are a few future improvements that we want to improve, such as the dye liner. Currently, we use something called graph oil, which is the graphite sheets that you see in the far right. Now, they rip very easily and are very hard to work with. So we want to switch onto a spray coating, such as the graphite lubricant, as you can see. And this will allow for easeability as well as it will help when we scale up the project. And we also want to change and go away from graphite tooling to tungsten carbide tooling, as this will allow us to work with higher pressures as well as lowering the temperatures. Thank you for listening, and I'm going to be ready for questions.